Hello there and welcome. I'm so glad you found your way here tonight. Maybe the day has felt a little too loud, a little too bright, a little too full of clocks and notifications and unfinished thoughts. Or maybe you are simply the kind of person who likes to fall asleep while drifting through enormous ideas, the sort that make ordinary worries feel small and soft around the edges. Either way, you are in exactly the right place. Tonight, we are not going to hurry anywhere. We are not going to solve every question. We are not going to demand neat answers from a cosmos that has never really spoken in neat answers. Instead, we are going to travel slowly through some of the most relaxing mysteries of our universe, the grand questions that still shimmer quietly at the edge of human understanding. So if you'd like to, settle in now. Let your shoulders drop. Let your jaw unclench. Let your breathing soften into whatever rhythm feels kind and natural. If you are listening in bed, perhaps you can sink a little deeper into the pillow. If you are under a blanket, feel its weight around you, gentle and grounding like a small private gravity of your own. There is nothing to do now except be here. You do not need to remember everything. You do not need to stay perfectly focused. In fact, this is one of those rare journeys where drifting is part of the design. If your thoughts wander, let them wander. If the facts blur into dreams, that is perfectly all right. You can simply listen and rest. The universe is often described as strange, violent, vast, and cold. And yes, it can be all of those things in one way or another. But at night, in the soft hush between waking and sleep, the universe may also feel different. It may feel patient. It may feel almost tender in its distance. Out there beyond roofs and trees and sleeping streets, beyond clouds and moonlight and the thin blue shell of our atmosphere, the cosmos continues its ancient, unhurried unfolding. Stars are being born. Galaxies are turning. Invisible forces are shaping structures too large for the mind to hold all at once. Light from unimaginable distances is still on its way, still crossing the dark, still arriving after journeys longer than entire civilizations. And somehow here you are, wrapped in blankets or shadows, listening to the story of it all. There is something deeply soothing about mysteries when they are not emergencies. A mystery of the universe is not like a missing key or an unanswered email. It is not a problem waiting impatiently for you. It is a doorway, a soft one, a star-shaped one, a doorway that reminds us how much there still is to wonder about. The universe does not become less beautiful because we do not fully understand it. If anything, its beauty may deepen there, in the half-known places, in the questions that remain open like quiet windows. Tonight we will move through some of those windows. We will visit invisible matter, the strange stretching of space, signals that flash across the cosmos for only a heartbeat, an ancient light that still carries the memory of a younger universe. We will pass by black holes, rogue planets, cosmic voids, whispering particles, possible hidden dimensions, and the soft, astonishing fact that anything exists at all. And as we go, I want you to remember that there is no rush. The universe has had billions of years to become mysterious. We do not need to understand it in the next hour. We can simply float beside its questions. We can look without grabbing. We can wonder without straining. That is the mood tonight, not a lecture, not a test. More like a slow lantern walk through cosmic darkness, where every few steps something lovely appears, glows for a while, and then fades into the next. If you enjoy these long, dreamy journeys through science and mystery, You might gently like the video or subscribe or save this one for another quiet night. Only if it feels natural. No pressure. The stars will not mind either way. But if this kind of calm, thoughtful wandering is your thing, I'd be very happy to have you here again. And if you are already part of this sleepy little corner of the cosmos, welcome back. You know the rhythm by now. We begin with curiosity, we move with softness, and somewhere along the way, hopefully, sleep finds you. Tonight's title is the most relaxing mysteries of our universe to fall asleep to, and I think that is exactly what we need. Not the scariest mysteries, not the loudest, not the ones dressed up to startle you. The relaxing ones. The ones that invite awe more than alarm. The ones that remind us that human knowledge, wonderful as it is, still rests on the shore of an ocean too wide to chart in full. There may be comfort in that. There may be freedom in it too. You are allowed not to know. You are allowed to rest inside unanswered things. So imagine, if you like, that we are stepping out onto a high, silent observatory balcony. The night air is cool, but not cold. The sky above is dark velvet scattered with silver points. Somewhere far beyond what the eye can see, galaxies gather like drifting cities of light. Somewhere deeper still, space itself is expanding, carrying distant islands farther apart. Somewhere in the oldest light, the baby universe still hums in microwaves so faint they can only be heard by instruments, never by ears. Somewhere invisible, dark matter is shaping the skeleton of the cosmos. Somewhere stranger still, the rules may bend or whisper or hide layers we have not yet learned how to perceive. And yet here in this room in this moment, your only task is to listen if you want to and sleep if you want to, and let these mysteries pass over you like slow constellations. You're doing great. There is nothing to solve tonight. Let yourself drift. Let the universe be large. Let your mind be small in the nicest possible way, held gently by scale, by silence, by wonder. Take one soft breath in, and one soft breath out, and when you're ready, we'll begin. One of the gentlest mysteries to begin with is also one of the oldest. Why is the night sky dark? It sounds almost too simple, too familiar to count as a cosmic puzzle. After all, night is dark because the sun has set. We learn that early. But if the universe were infinite, eternal, and evenly filled with stars in every direction, then in theory almost every line of sight should eventually end on the surface of a star. The sky should glow everywhere, bright and crowded, more like a wall of fire than a black ocean sprinkled with lights. And yet it does not. It opens above us as a deep, velvety darkness, generous and spacious, with stars scattered like thoughtful pauses. The reason may be that the universe has not existed forever in its present form, and that light from all places has not had enough time to reach us. Space also expands, stretching the light of distant objects, dimming and reddening it as it travels. So the darkness of night is not emptiness in the ordinary sense. It is history, it is distance. It is the sign of a universe with an age, with an unfolding story, with horizons and beginnings. Even the blackness above your roof tonight is not merely the absence of light. It is a clue, a soft answer hidden inside an even softer question. And perhaps that is a lovely way to start, because it means the calm darkness around us is not blank after all. It is meaningful. It is full of old light that has not yet arrived and some that never will. If we drift a little deeper, we reach another mystery made of light, though not the kind our eyes can see. All around us, in every direction, there is a faint afterglow from the early universe. a dim sea of microwave radiation left behind from a time when the cosmos was very young, hot, and dense. This ancient glow was released when the universe had cooled enough for light to finally move freely, after spending its earliest era trapped in a fog of charged particles. In a sense, this is the oldest light we can ever hope to observe, a baby picture of everything. It surrounds us constantly, quietly bathing the earth, the walls of your room, the pillow beneath your head, the air in your lungs. Not in any mystical way, just in the beautiful plain fact that the universe still carries a memory of its own beginning. And the mystery is not only that this glow exists, but that it is so smooth, so uniform, and yet not perfectly so. Tiny fluctuations, slight variations in temperature, became the seeds from which stars and galaxies eventually grew. That means the largest structures in the cosmos may trace their origins to minute ripples in this ancient light. It is astonishing to think of it. The galaxy that carries our sun, the elements in your body, the mind listening to this story, may all have roots in faint irregularities spread across a newborn sky. There is something almost lullaby-like in that thought. Greatness arising from tiny tremors. Vastness beginning in a whisper. And still, even that ancient light cannot tell us everything, because there is a limit to what we can see. The observable universe is exactly that. Observable, not total. Beyond a certain distance, space has expanded in such a way that light from farther regions has not had time to reach us since the cosmic beginning. There may be far more universe beyond our horizon, perhaps vastly more, perhaps endlessly more, but we cannot look past that luminous edge. It is one of the quietest and most humbling mysteries in science. Not just that there are things we do not yet know, but that there may be things we can never directly know because the geometry and history of space place them permanently beyond our sight. And yet that unseen beyond is not fiction. It may be as real as the stars above us, simply unreachable to our instruments. The universe, then, is not just large. It is layered with absence, framed by natural curtains. There is something soft about that, too. We are used to thinking of knowledge as a lamp that can keep expanding forever. But the cosmos may have built in a twilight boundary, a place where sight gives way to inference, and inference gives way to wonder. If that feels frustrating in daytime, at night it may feel almost merciful. The universe has edges to our knowing. It allows mystery to remain mystery. Then there is the invisible weight of dark matter, one of the grandest unknowns in modern cosmology. Galaxies spin too quickly for the gravity of their visible stars and gas alone to hold them together. Clusters of galaxies bend light more strongly than ordinary matter seems able to explain. Cosmic structure, on the largest scales, appears to have been shaped by a hidden scaffolding, a kind of silent architecture that does not shine, does not reflect, does not glow, and yet pulls with unmistakable gravity. Whatever dark matter is, it seems to make up far more of the universe's matter than everything we can see, and I find there is something almost serene about that. We like to think that what matters most is visible, but the universe may not work that way. Most of the gravitational glue in the cosmos may be entirely dark to the eye. Entire galaxies may be cradled by halos of invisible substance, like lanterns hanging inside clear, silent spheres we cannot touch. Scientists have proposed many possibilities: unfamiliar particles, ancient remnants, exotic forms of matter not yet directly detected. But for now, Dark matter remains more presence than identity, a hidden hand revealed only by its effects. It shapes without showing itself. It organizes without announcing itself. And somewhere in that invisibility there is a bedtime lesson too gentle to ignore. Not everything real needs to be seen to be felt. If dark matter is the unseen skeleton of the universe, dark energy may be its most mysterious breath. Long ago, many people expected cosmic expansion to be slowing down under gravity's patient pull. But careful observations revealed something stranger. The universe's expansion is accelerating. Galaxies on the largest scales are not merely coasting apart. Space itself seems to be stretching faster with time, as if some quiet pressure is urging the cosmos outward. We call this dark energy, though the name is really a placeholder, a respectful label for something not understood. It may make up most of the universe's total energy content, and yet we still do not know what it is. That is extraordinary. Most of reality, perhaps, is governed by something we cannot yet describe in a satisfying way. And still the effect is everywhere, soft and enormous. Every vast gulf between remote galaxies is slowly, steadily growing wider. The future night sky of far-off civilizations, if such civilizations exist, may hold fewer visible galaxies as the cosmos expands ever more. There is melancholy in that, yes, but also a kind of elegance. The universe is not static scenery. It is a living geometry, changing on scales too immense for any human lifetime to feel directly. Even now, while you lie resting, space may be opening itself very gently, like a flower no one can watch bloom in real time. And then there is the curious calmness of the universe itself. On the largest scales, it appears remarkably flat, remarkably smooth, remarkably balanced. This is strange, because tiny differences in the early cosmos might have grown into a wildly curved or chaotic universe instead. To explain this broad evenness, many physicists think there was an unimaginably brief early episode of explosive expansion called inflation, a sudden swelling that stretched space so dramatically that the visible universe became flattened and smoothed, the way a tiny wrinkle might disappear if you pull a cloth tight enough. Inflation is a powerful idea, elegant and useful, and yet still mysterious in its details. What caused it? What field drove it? Did it happen exactly as imagined, or only approximately so? We are left with hints, patterns, and the gentle precision of a cosmos that somehow emerged astonishingly orderly from primal intensity. It is one of those mysteries that feels especially restful, because it reminds us how much grace there can be in large-scale structure. The universe could have been less hospitable to stars, to chemistry, to calm skies, to wondering beings. But here it is, spacious and coherent enough for galaxies to form, and for one small species on one quiet planet to notice. There's no rush to understand all of it tonight. Just let that smoothness be a kind of background music, a deep structural hush, a reassurance written into space itself. Among the oldest cosmic questions is a small asymmetry with enormous consequences. Why does anything made of matter exist at all? In the earliest moments of the universe, matter and antimatter may have been created in nearly equal amounts. These opposites, when they meet, can destroy one another in flashes of energy. If perfect balance had held, the universe might have become almost all radiation, with no enduring atoms, no stars, no planets, no oceans, no sleeping listeners beneath blankets, no one to ask the question. And yet something tipped the scales. Very slightly, but enough. Somewhere in the first instance, matter seems to have gained the tiniest advantage, perhaps just a little extra for every vast crowd of pairs, and that tiny surplus became everything solid we know. The mystery is exquisite in its delicacy. All of this may exist because of a minute imbalance, a faint cosmic preference not yet fully explained. Physicists search for deeper reasons in the behavior of particles and symmetries, in laws that may have treated matter and antimatter just a little differently. But the full story remains unfinished. It is almost impossible not to feel wonder here. The table of elements, the mountains, the bones in your hand, the hush of your room, all may descend from a subtle unevenness in the young universe. Creation not from grand excess, but from the smallest surviving remainder. A residue, a leftover. A cosmic almost nothing that became everything we touch. Another mystery arrives in the shape of a shadow, the black hole. These objects are not holes in the ordinary sense, but regions of space where matter has been compressed so densely that gravity becomes overwhelming. Beyond a boundary called the event horizon, not even light can escape. That alone would make black holes dreamlike enough, but their deeper mystery lies in how they sit at the meeting place of theories that do not yet fit together comfortably. According to general relativity, gravity curves spacetime smoothly. According to quantum physics, nature is restless, granular, full of uncertainty and fluctuation. Black holes seem to demand both descriptions at once. They are cosmic places where our best frameworks press together and begin to whisper different things. When matter falls toward a black hole, information about it should, in some sense, still matter to physics. But how does that square with an event horizon that hides what entered? We know black holes exist with growing confidence. We have seen their effects, mapped stars orbiting invisible giants, watched space tremble as black holes merge, even glimpsed the glowing regions around them. And yet their interiors remain hidden from direct view, sealed behind the horizon like the ultimate curtained room. There is something almost soothing in the idea that nature still keeps such profound privacy. The universe does not reveal all its chambers at once. This leads naturally into one of the most elegant puzzles in all of science, the information paradox. In simple, sleepy terms, the problem is this. Quantum theory is very strict about information. It does not like the idea that information simply vanishes from reality, but black holes seem to threaten exactly that. If something falls in, and if the black hole eventually evaporates through an extremely slow quantum process, what happens to the information about what was lost? Does it disappear? Is it encoded somehow in faint outgoing radiation? Is it stored on the horizon, woven into spacetime in ways we do not yet understand? There are many proposed resolutions, and some are wonderfully strange. Some suggest the horizon may not be the quiet crossing we once imagined. Some suggest information leaks out in subtle patterns too delicate for us to read. Some hint that space itself may encode reality holographically, with surfaces carrying deeper truths about volumes. The details can become technical, but the bedtime heart of the mystery is very simple and very beautiful. Does the universe forget? And if it does not, where does memory live when stars collapse into darkness? It is such a haunting question, because we know something about memory ourselves. We know about keeping, losing, holding, fading. To find the cosmos asking its own version of that question makes the whole subject feel strangely intimate. Black holes become even more mysterious when we look back toward the early universe. There, far sooner than many models expected, astronomers find signs of supermassive black holes already shining as quasars, brilliant engines powered by matter falling inward at extraordinary rates. These giants seem to have grown up too quickly. It is as though the universe was still arranging its first cities of stars, and already some of these dark monarchs had taken their thrones. How did they become so massive so soon? Did they begin from unusually large seeds, perhaps from direct collapses of vast gas clouds? Did early conditions allow black holes to feed at astonishing speeds? Did some unfamiliar channel of growth operate in the beginning's dim chaos? We do not yet know. And that ignorance is not embarrassing. It is luminous. It means the first chapters of cosmic history still contain plot twists. Somewhere in the early dark, huge concentrations of matter formed and deepened, and began to shape their surroundings in ways our current stories only partly capture. Sometimes the universe seems patient. Sometimes it seems startlingly quick. Great darknesses bloomed before many expected them to, and from across billions of years their light still reaches us. Then there are the fast radio bursts, those sudden, millisecond flashes of radio energy that arrive from distant space like cosmic taps on a window. For a long time they were among the strangest signals we had. So brief, so bright, and so hard to trace. A burst lasts only a blink, yet can release an astonishing amount of energy in that tiny interval. Some appear only once. Others repeat. They race through the cosmic web, and in passing through diffuse matter between galaxies, they become slightly stretched in ways that help reveal what lies along their path. That means these mysterious flashes are not only puzzles in themselves. They are also probes, little lanterns briefly illuminating otherwise difficult-to-measure material in the vast spaces between galaxies. As for what causes them, the answer may not be singular. Some appear connected to magnetars, which are themselves among the universe's more dramatic objects. Others may arise from different astrophysical situations not yet fully sorted out. I love how these bursts change character depending on how you listen to them. By day they sound like data points, transients, unresolved phenomena. By night they feel like tiny knocks from unimaginable distances, brief bright syllables in a language we are just learning to hear. Not messages, perhaps, but still a kind of communication from the dark. And magnetars, those extraordinary neutron stars with magnetic fields of almost absurd intensity, deepen that feeling. A neutron star is already a marvel, the crushed core of an exploded star, a mountain-sized object with the mass of a sun-like star packed into a city-scale sphere. A magnetar is an even more extreme version, wrapped in magnetic power so tremendous it can twist the behavior of matter and radiation around it. Their crusts may crack. Their fields may rearrange violently. They can emit bursts of high-energy light, and in at least some cases, seem capable of producing fast radio bursts too. Yet magnetars are still not fully understood. Their interiors may contain exotic states of matter. Their sudden glitches in spin, their eruptions, their temporary brightenings all suggest a restless hidden structure. Imagine an object no wider than a modest town, spinning in darkness, carrying stresses beyond ordinary imagining, storing violence in silence until something shifts and it flares across the galaxy. And still, even here, there is something deeply calming in the scale of it. These distant convulsions do not disturb your room. They only remind us that the universe contains forms of matter stranger than old stories ever dreamed, and that even the dead cores of stars may continue to surprise us. Let yourself drift with that thought. Dead stars are not always quiet. Darkness is not always empty. And mystery, even when intense, can still be beautiful. Before we go any farther, let this be a soft place to pause. You have already traveled a long way tonight, from the darkness of the night sky to invisible matter, from ancient light to black holes and brief radio whispers crossing the universe. And you do not need to hold all of it tightly. You can let it wash through. You can let the details loosen and blur around the edges. Take a slow breath in if that feels nice, and let it out gently. Feel the bed beneath you, or the chair beneath you, or simply the steady support of whatever is holding you up right now. Feel the air around your face. Notice that while the universe may be full of unanswered questions, in this moment your job is very small and very kind. Rest. Listen if you want to. Drift if you want to. Sleep if sleep is arriving. There is something comforting in remembering that the biggest mysteries do not demand anything from you. Dark matter does not need solving tonight. Black holes are not waiting impatiently at the foot of the bed. The ancient light of the cosmos has already traveled for billions of years. It can wait while you get comfortable. You're doing great. There's no rush. Let your thoughts float like distant galaxies with plenty of space between them. And when you're ready, we'll continue our slow journey deeper into the calm and curious night. If we continue gently onward, we come to the interiors of neutron stars, places so extreme that even our best theories become tentative and careful. A neutron star is what may remain when a massive star ends its life in a supernova, and its core collapses under gravity. But saying that is almost too tidy for what these objects really are. They are matter pressed so tightly that atoms are broken, electrons and protons crushed together, structure reduced to something radically denser than anything we can make or touch on Earth. And still, we are not entirely sure what the inner arrangement becomes. Perhaps layers form, with a crust above stranger and stranger phases beneath. Perhaps particles appear there that are rare or unstable elsewhere. Perhaps the deepest core holds forms of matter that exist nowhere else in the observable universe. We infer these possibilities from observations, equations, and the behavior of spinning, pulsing stars at a distance, but the exact story remains open. The mystery is not only about density. It is about how matter behaves when pushed beyond familiar boundaries. It is nature under impossible pressure. Sometimes I think one of the universe's sweetest habits is this. It keeps inventing environments so unusual that our ordinary categories soften and fail. Rock, gas, plasma, particle, fluid, solid, all begin to blur. The cosmos does not always respect the neat shelves of human language. And that may be a good lullaby in itself, a reminder that reality is wider than vocabulary. Then we meet the quasars, some of the brightest objects in the universe. visible from unimaginable distances because of the furious activity around supermassive black holes. Matter spirals inward, heats, glows, and can outshine entire galaxies. Some quasars appear from a time when the universe was still quite young, which makes them feel almost impossible, like lighthouse beacons lit in the dawn before the coastline was fully built. They are windows into the cosmic morning, telling us that great engines of gravity and light were already operating when the universe was in its youth. But how did some of them become so large and so luminous so early? That question still glimmers unanswered. There is something wonderfully paradoxical about quasars. They are signs of darkness so deep that light cannot escape once it crosses the horizon. And yet they are also among the most luminous things we know because of everything happening just outside that boundary. In that sense, they feel almost poetic, brilliance gathered around mystery, radiance born from falling inward. And from billions of light years away, they arrive as patient evidence that the early universe was not simple. It was creative very quickly. It built enormous structures, fed ravenous centers, and scattered clues across time for future minds to find. You do not need to decipher all of those clues tonight. It is enough to picture their distant glow. In beautiful contrast to quasars which blaze, there are the cosmic voids, regions of space where relatively little matter gathers. These are not perfect emptiness, but they are vast underdense expanses between the filaments and clusters of the cosmic web. If galaxies are like lanterns suspended on a grand invisible net, the voids are the silent rooms between the threads. They can be immense, spanning distances so large the imagination struggles to give them shape. And yet even these sparse regions matter. They help define the structure of the universe by contrast. They reveal where matter is not, and therefore where gravity has guided things to be. But voids also carry a soft mystery. Why are they the sizes they are? How do they evolve precisely? What can they teach us about dark energy, gravity, and the growth of large-scale structure? Some of the quietest places in the cosmos may help answer some of the loudest questions in cosmology. I find that deeply comforting. Even emptiness has information. Even absence tells a story. Even the places with almost nothing in them are not meaningless gaps. They are part of the pattern, part of the breathing room of the universe. Like pauses in music, voids help define the shape of what surrounds them. And then there is the Great Attractor, one of those names in astronomy that sounds like a bedtime story all by itself. It refers to a region of space toward which our galaxy and many others seem to be moving, drawn by the gravity of a vast concentration of mass. But this is not a single tidy object waiting to be photographed in full. It is more like a complicated landscape of clusters, superclusters, hidden structures, and matter distributed across a region difficult to map clearly, especially because much of it lies behind the dense plane of our own Milky Way. So here we are, drifting through the cosmos on a galaxy that itself is in motion, part of a larger flow toward something partly concealed from view. There is such softness in the phrase Great Attractor. It sounds like a mythic destination, a gravitational valley in the larger terrain of space. Yet the real beauty is that it reminds us the universe is not still at any scale. Galaxies move within groups, groups within clusters, clusters within broader cosmic currents. Even our home is participating in a dance whose full choreography we are still learning. You may be resting motionless right now, but the Earth is turning. The planet is circling the sun circles the galaxy, and the galaxy itself is part of a deeper drift. Stillness, it turns out, is often local. Another quiet mystery concerns the missing ordinary matter of the universe. Not dark matter this time, but ordinary matter, the kind made of protons and neutrons, the kind that builds stars, gas clouds, oceans, skin, stone, and breath. For a long while, when astronomers counted up how much of this ordinary matter should exist based on the early universe, a large fraction seemed missing from the nearby cosmos. It had not vanished in any magical sense. It was simply hard to find. The answer seems to be that much of it is spread thinly through the spaces between galaxies, woven through filaments of the cosmic web as extremely diffuse hot gas. Hard to see directly, easy to overlook, and yet present. Some of the very fast radio bursts we mentioned earlier have helped illuminate this ghostly material by showing how their signals are delayed and dispersed while crossing it. I love this mystery because it is really a story about subtlety. The missing matter was not dramatically stolen. It was softly hidden, diluted through immense volumes, waiting for the right methods to reveal it. Sometimes the universe hides its things not behind locks, but in thinness, in quietness, in forms that refuse to stand out unless you listen carefully. And listening carefully is exactly what we do when we return to the ancient sky of the cosmic microwave background, and notice that it is not entirely as expected. On the largest scales, there are anomalies that continue to intrigue cosmologists. A broad cold spot, an asymmetry between opposite hemispheres of the sky, fluctuations that do not match the simplest predictions as neatly as hoped. These features may have mundane explanations, subtle statistical quirks, or they may hint at deeper physics not yet understood. Perhaps some structure along the line of sight has affected the light. Perhaps the earliest conditions were slightly more complicated than our cleanest models assume. Or perhaps the universe is whispering that its symmetry is not complete. Whatever the case, the oldest light still contains little irregularities of character, little raised eyebrows in the baby portrait of the cosmos. I find this endearing. Even the universe in its infancy may have had quirks. It was nearly uniform, nearly perfect, nearly simple, but not entirely. And those gentle imperfections are part of what made later structure possible. A world without variation would have been a world without galaxies. So when you hear about cold spots and asymmetries and deviations from expectation, you need not think of them as failures. Think of them as texture. Think of them as the universe declining to be boring. Think of them as tiny cosmic signatures in an otherwise smooth expanse, reminders that wonder often lives in the places where pattern and surprise meet. One of the most elegant modern puzzles is known as the Hubble tension, and although the name sounds technical, the basic mystery is beautifully simple. When astronomers measure how fast the universe is expanding using the nearby universe, by building careful distance ladders from stars and exploding stars and galaxies, they get one value. When they infer the expansion rate from the early universe, using the ancient afterglow of the cosmos and the standard model of cosmology, they get another. These values are close, but not close enough to rest comfortably together. The difference has persisted through improving measurements, and that makes the problem more intriguing, not less. It raises the possibility that something subtle but important is missing from our understanding of cosmic history. Perhaps there is some new ingredient in the universe's behavior. Perhaps some assumption in the model is incomplete. Perhaps the connection between the young cosmos and the present-day one contains a chapter we have not fully read. I love this mystery because it is not a dramatic rupture. It is more like a slight musical dissonance in an otherwise beautiful symphony. A note that does not quite resolve. A gentle mismatch that keeps cosmologists awake while the rest of the world sleeps. And maybe that is one of the nicest forms a scientific mystery can take. Not a collapse, not a crisis, just a persistent invitation to look again. Then, from far beyond our solar system, there came a visitor with a name that felt like poetry. Oumuamua, often translated as a messenger from afar arriving first. It was the first confirmed interstellar object seen passing through our solar system, a wanderer from another star's domain. That alone would have been enough to make it memorable, but it also behaved in ways that made it especially fascinating. It appeared elongated in an unusual way, changed brightness dramatically as it spun, and later seemed to accelerate slightly as it departed, without showing the obvious dusty coma one might expect from a comet. Explanations have been proposed. Perhaps it was an oddly shaped natural body, perhaps a fragment, perhaps outgassing occurred in a subtle or difficult-to-detect way. The simplest answer may still be a natural one, and yet the object remains a wonderful case study in how the unfamiliar can feel almost storybook-like. A reddish traveler, wandering the Milky Way for ages, slipping briefly past our sun before disappearing again into the dark. There is no need for sensationalism. Reality is already soft and strange enough. Oumuamua reminds us that the space between stars is not necessarily empty of travelers. Things drift there for unimaginable spans of time. Some may cross from system to system, carrying the chemistry and scars of other suns. And sometimes, if we are lucky, one passes close enough for us to notice, just long enough to deepen the night. Some worlds may travel alone not because they came from another star, but because they belong to none. Rogue planets, also called free-floating planets, may drift through the galaxy untethered to any sun, dark and cold, and difficult to detect. Some may have been thrown out of young planetary systems during chaotic gravitational encounters. Others may have formed more directly from collapsing clouds, something like tiny starless worlds born in solitude. The idea is both eerie and peaceful. Planets wandering in the dark, with no dawn, no noon, no regular sunset, only the faint, distant shimmer of stars that never become a local sun. And there may be many of them, perhaps more than we once expected. Because they emit little light and are hard to see, astronomers often rely on gravitational microlensing, those brief amplifications of background starlight when a rogue planet passes in just the right place. It is such a tender method of discovery, noticing the unseen by the way it bends something else. There is a profound bedtime softness in rogue planets. They are cosmic castaways, perhaps, but not failures. They are simply another category of existence the universe allows. Not every world must circle a star. Some may spend eons in darkness, carrying their own silence through the galaxy. Let yourself drift with that image for a moment. A lonely planet, but not a tragic one, gliding peacefully through interstellar night. And then there are gravitational waves, which brought us one of the most astonishing confirmations in modern physics. Space-time itself can ring. When massive objects such as black holes or neutron stars spiral together and merge, they disturb the fabric of space-time in a way that sends ripples outward at the speed of light. By the time these ripples reach Earth, they are incredibly faint, smaller than intuition is comfortable with, and yet we have learned how to detect them. This is extraordinary not only because it verifies a deep prediction, but because it opens an entirely new sense for the universe. We are no longer only looking at the cosmos through light. We are also, in a very real way, feeling its vibrations. But the mystery is not finished. How many kinds of hidden mergers are out there? What unknown populations of black holes and neutron stars remain to be counted? Might gravitational waves one day reveal traces of even earlier cosmic events, perhaps from the infant universe itself? The night becomes deeper when you realize that the dark is not silent. It is full of motions that do not glow. There are collisions no eye could ever see directly, yet the universe still communicates them by a trembling in geometry itself. A lovely thought for bedtime. Even space can hum. High-energy cosmic rays bring another kind of mystery, one with a slightly sharper edge but still a quiet fascination. These are particles, often protons or atomic nuclei, arriving at Earth with astonishing energies, some so great that their origins remain difficult to explain. Where exactly are the most extreme ones accelerated? Which cosmic engines can launch them across intergalactic distances? Active galactic nuclei, shock waves, violent environments around black holes or exploding stars may contribute, but the full picture is still incomplete. The difficulty comes partly from the fact that charged particles do not travel in straight lines through cosmic magnetic fields. They wander, curve, and lose their direct trail back to the source. So when one reaches our planet, it arrives like a traveler who has taken too many turns to reconstruct the original road. That makes cosmic rays feel mysterious in a wonderfully old-fashioned way. They are messengers whose envelopes have been weathered and folded. We receive them, we measure their energy, we study their composition, and still the path behind them is partly hidden. Even now, the universe is sending energetic fragments into our atmosphere, and we continue trying to trace the broader story from these scattered arrivals. It is cosmic detective work performed with patience, mathematics, and a willingness to accept partial maps. And finally, in this section, let us drift toward one of the strangest possibilities: primordial black holes, hypothetical black holes that may have formed not from dying stars, but in the very early universe itself. If such objects exist, they could range across a remarkable variety of sizes, depending on the conditions of the newborn cosmos. They have been proposed at times as potential contributors to dark matter, or as clues to the physics of the first moments after the beginning. But no definitive evidence yet tells us they are real. They remain possibility more than presence. I find that very relaxing, because primordial black holes sit at a beautiful intersection between imagination and rigor. They are not fantasy. because the laws of physics may permit them under certain early conditions. And they are not established fact, because nature has not yet clearly shown us one. So they hover in that delicious middle region where science is most dreamlike, disciplined speculation. Maybe the infant universe was lumpy enough in places for gravity to pinch little black holes into being. Maybe some still wander through the cosmos, ancient and dark, older than stars. Maybe not. Either way, the idea reminds us that the beginning of the universe may have left relics we have not yet recognized. The first chapters are still sending footnotes forward in time. Let's slow down again here. If your thoughts are beginning to blur a little, that is not a problem. That is part of the beauty of listening at night. Some ideas stay sharp and some dissolve softly into the next. The universe is still there either way. Take a comfortable breath in and let it go. Notice how the room feels now compared with a few minutes ago. Maybe quieter, maybe heavier with sleep. Maybe lighter somehow, as if the mind does not need to grip the day quite so tightly anymore. You have wandered past strange visitors from other stars, planets with no suns and ripples moving through space-time itself. And now, for a moment, you do not need to travel anywhere at all. You can simply float. There's nothing to do now except be here. Let your hands rest. Let your eyelids be as heavy as they want to be. If you miss a sentence, that's all right. If you drift away for a while and come back later, that's all right too. The mysteries of the universe are patient companions. When you are ready, we will keep going softly, deeper into questions about time, infinity, empty space, and the quiet architecture of reality itself. In a way, the mystery of matter and antimatter does not end in the early universe. Even now, space occasionally offers hints and puzzles involving antimatter particles, such as positrons, the antimatter partners of electrons. Certain regions and processes in the cosmos produce them, and detectors have found unexpected excesses in some contexts that continue to provoke discussion. Perhaps pulsars contribute. Perhaps energetic astrophysical processes explain the pattern. Perhaps something more exotic plays a role. The details are complicated, but the soothing heart of the mystery is this. Even in today's universe, the old question of symmetry has not completely fallen silent. Tiny opposites still appear, still vanish, still leave delicate statistical fingerprints for us to interpret. There is a strange elegance in that. The early imbalance that allowed our world to exist did not end the dialogue. It only made the conversation quieter. Somewhere in the dark, matter and antimatter still meet in fleeting encounters, brief reunions of opposites that release light and leave us with one more clue and one more reason to wonder. Another mystery, one so close to everyday life that we almost stop noticing it, is the arrow of time. Why does time seem to move in one direction? Why do we remember the past and not the future? Why does cream swirl into coffee but not usually separate itself back out? Why do things age and scatter and soften instead of spontaneously reassembling? On the deepest level, many physical laws do not strongly prefer a direction in time. And yet the universe we inhabit plainly does. One popular way of understanding this is through entropy, the tendency for systems to move from more ordered states toward more probable, less ordered ones. But this explanation opens a deeper mystery. Why did the universe begin in such an extraordinarily low entropy state that allowed a long arrow of time to unfold at all? That question reaches far back, into the conditions of the beginning itself. It is one of the grand hidden asymmetries of existence, and at night, it can feel less like a problem than like a tide. We live inside a current flowing from simpler to more mixed, from earlier to later, from memory toward possibility. Sleep itself is a kind of surrender to that current. There may be comfort in knowing that time's direction is not merely your private experience. It is something written into the larger shape of the cosmos. From there, it is only a small dreamy step to perhaps the largest question of all. What, if anything, came before the beginning? The phrase before the Big Bang may be misleading if time itself began with that event or with the earliest state we can describe. Still, the human mind reaches naturally toward the edge and asks what was on the other side. Some models suggest bouncing cosmologies, where an earlier contracting phase preceded our expansion. Some imagine quantum beginnings, where the usual idea of time becomes fuzzy near the origin. Some say the question may simply not be well formed, like asking what lies north of the North Pole. And maybe that is true. But even if the question is partly shaped by the limits of human language, it remains beautiful. It shows the mind leaning against the boundary of its own intuitions. Beginnings are mysterious enough in daily life. Cosmic beginnings are almost too large to fit in the same category. And perhaps that is what makes them restful to contemplate at bedtime. You do not need a final answer. You can simply feel the strangeness of a universe that may have a first meaningful moment, and of a species clever enough to notice how strange that is. Then comes the question of size. Is the universe finite or infinite? The observable universe is finite in the sense that we can only see a limited region, but the total universe may extend far beyond that horizon. It may curve back on itself in some immense way. It may be finite but unbounded, like the two-dimensional surface of a sphere generalized into higher dimensions. Or it may truly be infinite, continuing without end, with regions forever beyond reach. Each possibility is astonishing in its own way. A finite universe large beyond comprehension is humbling enough. An infinite one is almost impossible for the mind to hold. Infinity is not merely very big. It is a different category altogether, something that stretches thought until thought becomes thin. But perhaps that is precisely why it feels so strangely calming at night. When the mind encounters something too large to master, it sometimes relaxes. It stops trying to own the whole picture. It settles into awe. Whether the universe ends somewhere beyond our view or goes on without boundary, the practical emotional result is similar. Reality is wider than our maps, and that is all right. Let yourself rest in that wideness. Closely related is the mystery of cosmic topology, the actual shape and connectedness of space on the largest scales. Even if the universe is broadly flat, that does not fully tell us whether space might wrap around in subtle ways, like a cosmic hall of mirrors on scales beyond current detection. In principle, light traveling through a multiply connected universe could produce repeated patterns or ghost-like copies of structures seen in different directions. So far, observations have not revealed clear evidence for such wraparound behavior, but the possibility remains one of those quietly enchanting scientific ideas. Imagine living in a universe where going far enough in one direction might, in some grand topological sense, bring you around again. Not because space is small in any ordinary way, but because its geometry is more playful than our everyday intuition. We often treat space as the most obvious thing, the neutral stage on which events happen. Yet on cosmic scales, even the stage itself may hold secrets. Space may have texture beyond texture, shape beyond the simple emptiness we imagine. There's something very sleepy and lovely in realizing that even emptiness might be folded with hidden grace. And then we arrive at empty space itself, which may not be empty at all. Quantum physics suggests that the vacuum is restless, alive with fluctuations, fields, and temporary happenings too subtle for ordinary senses. Space, when stripped of particles, is not necessarily a blank void. It may be the seat of background energy, potentiality, and virtual activity. This possibility becomes especially mysterious when linked with dark energy, because the energy of empty space has often been considered as one possible explanation, though the numbers are notoriously difficult and puzzling. Theoretical expectations and observed cosmic acceleration do not line up in a comfortable, simple way. So the vacuum becomes one of the most familiar seeming and least understood ingredients in physics. What is nothing, really? Not a philosophical nothing, but physical emptiness. Is it calm? Is it fertile? Is it structured by fields we barely comprehend? Tonight you need not wrestle with the equations. It is enough to enjoy the image of empty space as not dead but quietly active, not hollow but humming, not a blank page but a subtle ocean. The room around you may look still. The cosmos may look still. Yet underneath there may be a soft, continual flicker of possibility. If empty space is not truly empty, then perhaps the deepest scales of reality are stranger still. Some physicists speak of quantum foam, a poetic phrase for the possibility that at unimaginably tiny distances, space-time itself may be less smooth than it appears, perhaps frothy, fluctuating, uncertain in structure. This idea emerges where gravity and quantum theory begin to overlap in regimes we do not yet fully understand. On everyday scales, space-time feels serene and continuous. Even on planetary and stellar scales, it behaves with magnificent grace. But descend far enough, perhaps toward the smallest meaningful lengths, and that apparent smoothness may give way to something jittery and unfamiliar. The universe, which seems so calm from afar, may have a delicate grain at its foundation. I love how this mystery turns scale inside out. We often assume that the weirdness lies far away among galaxies and black holes. But some of the deepest uncertainties may lie not in the largest things, but in the smallest fabric underneath everything. The floor of reality may not be a floor at all, but a trembling surface we have not yet learned how to stand on conceptually. And still, none of that disturbs the softness of this moment. Your blanket remains a blanket. Your breath remains a breath. The unknown can exist beneath the familiar without stealing its comfort. From there, it is an easy glide into the idea of hidden dimensions. We move through 3 dimensions of space and one of time, at least in ordinary experience. But some theories have suggested that additional spatial dimensions may exist, curled up so tightly or hidden so effectively that we do not perceive them directly. These ideas are motivated partly by attempts to unify physics, to make gravity and quantum theory speak more fluently to one another. Whether nature truly uses extra dimensions in this way remains unproven, but the concept is irresistible in its bedtime gentleness. Imagine that the world you know is complete for daily life, but not complete in ultimate structure. Imagine that reality contains directions not available to ordinary movement, folded into scales too small to notice. It is like learning that a simple-looking melody contains harmonies too faint for casual hearing. Extra dimensions may or may not be real in the way certain theories hope, but their very possibility is a reminder that perception is not the same as totality. There may be more room in existence than the senses report, more architecture than the eye can map, more doors in the house than the sleepy resident has ever opened. And of course, once one admits the possibility that reality may be larger, stranger, or more prolific than it appears, the multiverse enters like mist through an open window. There are many forms of multiverse ideas. Some grow from inflation, suggesting that different regions of a much larger reality may have expanded into separate bubble universes. Others emerge from quantum interpretations or from landscapes of physical laws. It is important to say softly that these are speculative ideas, with very different degrees of testability and rigor depending on the framework. Still, the reason they persist is that they are not merely fantasy. They arise naturally enough from certain serious attempts to understand the cosmos, and what a strange comfort they carry. If our universe is one region among many, then what we call everything may be only local everything. Our laws, our constants, our cosmic history may be one chapter in a much larger library. This does not make our own universe smaller in any emotional sense. It makes it more precious, perhaps, more distinctly itself. One room in an unimaginable palace. One shell on a shore without end. You do not have to decide whether the multiverse is true tonight. You can simply feel the gentle widening that comes from the possibility. Then there is the famous silence often called the Fermi paradox. If the universe contains so many stars, so many planets, so much time, where is everybody? Perhaps life is common but intelligence rare. Perhaps intelligence arises often but does not last long. Perhaps civilizations are quiet, distant, uninterested, or separated by such scale, and timing that contact is naturally improbable. Perhaps life flourishes mostly in simple forms. Perhaps we have not yet learned how to listen. Or perhaps the universe is, in practice, far lonelier than our hopes and numbers suggest. This mystery can sound unsettling when framed harshly, but tonight let us frame it more gently. Silence is not necessarily emptiness. The forest at night is full of life even when no bird sings at that moment. The ocean can be crowded with creatures far below a calm surface. Our listening has only just begun on cosmic timescales. We are beginners, standing on the shoreline with a shell to our ear, wondering whether the sea contains other songs. It may. It may not. The uncertainty is real, but so is the tenderness of the question. We ask because we are social beings, curious beings, beings who imagine company in the dark. Linked to that is the ongoing mystery of possible life on worlds beyond our own. We have discovered thousands of exoplanets, with many more likely awaiting detection, including worlds in temperate zones, worlds covered in gas, worlds perhaps rocky and Earth-sized, worlds orbiting dim red stars, worlds unlike anything in our own system. Some atmospheres may one day reveal hints of chemistry associated with biology, but interpreting such signs will be delicate. A gas alone is not a confession. A spectrum is not a handshake. Even if we detect something suggestive, there will be questions about geology, photochemistry, false positives, unfamiliar ecosystems. And that is part of the beauty. Life, if it exists elsewhere, may not announce itself loudly. It may disclose itself by nuance, by imbalance, by the persistent presence of molecules that should not coexist so easily. We may first recognize alien life not by seeing a creature, but by noticing that a planet's air is behaving too artfully. There is something exquisitely bedtime about that. Life as atmosphere, biology as a faint signature in starlight, the possibility that whole living worlds may currently circle distant suns while we sleep, breathing under skies we cannot yet imagine. And perhaps the strangest mystery of all is not out there but here. How does the universe become aware of itself? How does matter, arranged through stars and chemistry and evolution, eventually begin to wonder? Consciousness remains deeply mysterious even before we place it in cosmic context. We can describe brains, neurons, signals, patterns, correlations. But subjective experience, the inwardness of being, the fact that there is something it feels like to be a living creature, still resists full explanation. And yet here consciousness is, listening to a story about galaxies. Carbon formed in stars, assembled through planetary and biological history, has become capable of asking where stars came from. If that does not feel miraculous, at least in the old poetic sense, it is hard to know what would. Maybe consciousness is a common flowering of complex matter. Maybe it is rare. Maybe it will one day be better explained. But for now, it remains one of the most intimate mysteries in the universe. Not merely what the cosmos is, but how some part of it can feel anything at all. If you are half asleep now, perhaps that question can drift past you like a final lantern. The universe, through you and others like you, has developed the ability to be moved by its own night sky. This is another good place to soften. If your mind feels far away now, that is perfectly fine. Maybe the words are turning into pictures. Maybe the pictures are turning into feelings. Maybe even those are fading now into that pleasant, blurry edge where sleep begins to gather. Take a slow breath in, and a slower breath out. Feel how small this moment is compared with the age of the universe and how lovely that smallness can be. You do not need to hold infinity. You only need to rest inside one quiet night. There's no rush. Let your thoughts become spacious. Let each mystery open and then drift away, like a door swinging closed very gently. Hidden dimensions can wait. Other worlds can wait. The oldest light in the universe has already been patient for billions of years. You can simply listen and rest. And in a moment, we'll make our final stretch through a few last cosmic mysteries, before we settle everything back down into stillness. One mystery that has long fascinated scientists and philosophers alike is the apparent fine-tuning of the universe. Certain physical constants and conditions seem to lie within ranges that allow stars to burn steadily, chemistry to become rich, and structure to form. If some values were very different, the universe might have expanded too quickly for galaxies to gather, or collapsed too soon, or produced a chemistry too simple for complexity to bloom. The question is not always framed the same way. Some see fine-tuning as a sign that deeper principles remain to be discovered, principles that would one day show these values could not have been otherwise. Some point to selection effects. Of course, we find ourselves in a universe compatible with observers, because only such a universe could be noticed by beings like us. Others connect the puzzle to multiverse ideas, suggesting many different cosmic settings may exist, with ours being one of the habitable ones. But whatever interpretation you prefer, the raw feeling remains deeply moving. The universe is not merely large. It is delicately workable. It is a place where complexity can persist, where stars can forge heavy elements, where planets can cool, where life can emerge and ask questions. That delicacy itself becomes a mystery, not in a threatening way, but in a hushed one, a quiet astonishment in the background of everything. Then comes the question of ending. What will become of the universe in the far future? If dark energy continues to drive expansion, galaxies beyond our local group may recede ever farther, leaving future skies emptier. Stars will slowly burn out. New star formation may diminish as gas is used up or scattered. Black holes may dominate certain eras, and over fantastically long spans even they may fade through evaporation, if our theories are right. This broad picture is often called heat death, not because of fiery destruction, but because of a thinning out of useful energy differences, a drift toward a colder, quieter, more diffuse cosmos. Other possibilities have been imagined too, including more dramatic fates depending on the exact nature of dark energy or the deeper laws of physics. But the most serene vision is perhaps the one of gradual dimming, a universe becoming more spacious, more silent, more sparse. At first that may sound sad, yet at bedtime it can also feel strangely peaceful, like the final hush after a very long song. The universe may not end with a shout. It may relax into stillness. Eons beyond eons, light thinning, structures fading, dark widening. Not tonight, not for anything remotely close to human timescales, but as a deep time lullaby, it is hauntingly gentle. At the centers of many galaxies, including our own, reside supermassive black holes, immense anchors whose histories intertwine with the histories of the galaxies around them. We know they are there by the motions of stars and gas, by the radiation from matter falling inward, by the structures they help influence. Yet much remains mysterious about how galaxies and their central black holes grow together. Which shapes which more strongly? Does the black hole regulate star formation by blasting energy outward during active phases? Does the galaxy's supply of gas determine the black hole's feeding life? The relationship seems intimate, almost conversational, as if galaxies and their hidden centers co-author one another across cosmic time. It is beautiful to imagine a galaxy not as a random scattering of stars, but as part of a long-term dance with a dark, invisible heart. Our own Milky Way carries such a heart, quietly resting compared with more active galactic nuclei, but still there, still central, still one more reminder that behind familiar starry beauty may lie a gravitational depth of astonishing scale. The night sky above us looks peaceful, and it is, but tucked inside that peace are unseen centers, quiet authorities shaping the broader architecture. There is also the mystery of the first stars, the ones that lit up the universe after the long dark ages that followed the release of the oldest light. Before stars formed, the cosmos was full of simple gas, cooling and gathering under gravity. Then at some point the first stellar fires ignited, ending the early darkness and beginning the grand age of starlight. We have not directly seen those first stars in detail. They are too distant, too early, too lost in time. But we can infer their existence, their role, and some of their likely properties. They may have been very massive. They may have lived briefly and died spectacularly, forging the first heavier elements that later generations of stars would inherit. In a sense, the first stars were the opening candles of complexity. Before them, the universe was simpler. After them, chemistry could become richer, planets eventually possible, biology eventually imaginable. Yet the exact timeline and character of this cosmic dawn remain active areas of discovery. And there is something so restful in thinking of the universe as once dark, then slowly becoming luminous. Not all at once, not in a single dramatic switch, but gradually, region by region, as the first fires woke up in the vastness. It mirrors, in some tender way, the transition between sleep and morning, or perhaps the reverse, as the mind lights one last thought before drifting off. Closely connected is the era of reionization, another beautifully hidden chapter in cosmic history. After the first atoms formed, the universe entered a neutral phase, with hydrogen gas filling much of space. Then, as the first stars and galaxies began shining, their energetic radiation altered that gas, gradually reionizing it. This transformation changed how light traveled through the universe and marked a major transition from one cosmic era to another. But the details of when and how this happened, which sources contributed most, and how patchy or extended the process was, are still being refined. In other words, the universe did not simply switch on. It passed through a foggy dawn, where early sources of light slowly changed the nature of the surrounding medium. I think that is one of the most soothing images in all of cosmology. A fog lifting across the young universe as the first luminous structures spread their influence. It reminds us that clarity often comes gradually. The cosmos itself had a misty morning. It had its own long awakening. And we, billions of years later, are still piecing together the memory of that dawn by catching the faintest traces left behind. And finally, the last mystery is perhaps the oldest and softest of all. Why is there something rather than nothing? Not merely why matter instead of antimatter, not merely why these laws instead of others, not merely what happened at the beginning, but why there is any reality at all for beginnings to happen in. This question may live partly beyond the reach of physics as physics is usually practiced. It may ask for philosophical language, or perhaps for a humility that accepts no complete answer may ever come. But it belongs here tonight because it gathers all the others under one wide umbrella. Dark matter, dark energy, time, consciousness, galaxies, black holes, ancient light, all of it rests on the more basic astonishment that anything exists in the first place. There could perhaps have been no space, no law, no energy, no story. And yet here there is a world, here there are stars, here there is sleep approaching in a room on one small planet, here there is the sound of a voice describing mysteries. If that question feels too big to answer, good, it should. Some questions are not ladders to climb but skies to lie beneath. Tonight let this one be a sky. Do not solve it, just rest under it. Let it be the final vastness, the final soft astonishment. Something exists. You exist. The universe is here. And for now, that is enough. And now, very gently, we come to the end of our journey. Tonight we wandered through darkness and ancient light, through invisible matter and expanding space, through black holes and radio flashes and lonely planets drifting without a sun. We moved through questions about time, about beginnings, about the shape of emptiness, about the possibility of other worlds and the mystery of consciousness itself. We followed the oldest light we can see, and we stood beside mysteries so deep that even our best ideas still glow only dimly at the edges of them. And through all of it, the universe remained what it has always been: vast, beautiful, unfinished, and wonderfully under no obligation to become simple just because we ask it to. Maybe that is one of the reasons cosmic mysteries can feel so calming at night. They remind us that uncertainty is not always a threat. Sometimes uncertainty is a meadow. Sometimes it is a sky. Sometimes it is a soft and spacious place where the mind can lie down for a while without having to fix anything. You do not need to understand dark energy before morning. You do not need to choose a final theory of the universe before sleep. You do not need to decide whether space is infinite, whether there are hidden dimensions, whether life is common, or what the vacuum truly is. Tonight, it is enough simply to have visited these questions. Enough to let them pass over you like slow constellations. Enough to feel, perhaps, that your own life sits inside something immeasurably larger and that there can be peace in that. Because when the universe becomes very large in the mind, our ordinary troubles sometimes become quieter. Not because they are unreal and not because they do not matter, but because scale can be kind. Perspective can be soft. The cosmos does not erase your life. It holds it. It reminds you that you are a small but genuine part of a very long story. The atoms in your body were shaped by old stars. The breath moving in and out of you belongs to a planet that moves through a galaxy that moves through a broader cosmic web. Even your sense of wonder is part of nature, part of the same universe that made quasars and magnetars and the oldest light. You are not outside the story listening in. You are one of the ways the story is being heard. So if your thoughts are still busy, let them slow now. They do not need to carry the whole sky. If you are still awake, that is all right. You can,